Okay, let's get busy here. Sum and difference formulas. Guys, these are also identities. It's kind of a little bit different if you realize we're going to be plugging in some values, because that's why I asked you to grab your unit circle, right? So you will see in just a second why it's helpful to have these values that we wrote kind of in the margin here with the common denominator for these different values. Those are your special angles on your unit circle, right? Okay, let's talk about these there's two sets of formulas, I should say, that we're going to look at today, and they are referred to as the sum and difference formulas. So we're going to look at the sum and difference formulas for cosine and for sine today. All right, a couple of things to notice. Yes, I will give you these formulas so you don't have to memorize them, but it's helpful to notice a few things about the formulas, right? So we're going to look at the cosine first. If you notice, I've got that highlighted. We're doing cosine first, right? If we take the cosine of two angle measures that are getting added together, that's what this first line is saying. If we take the cosine of two special angles that are getting added together, then the identity tells us that this is how we're going to plug in. We're going to take the cosine of the first angle times the cosine of the second angle, and then we're going to subtract. Notice the sign switch, right? We have a plus here, and it becomes minus here. And then we're subtracting from that the product of the sine values for those angle measures, okay? So you got to kind of see some examples about how this works. Similarly, with this cosine of two angle measures that are being subtracted, the key is realizing the difference with the sines and the fact that the cosines are together and then the sines. So that kind of helps you designate or pick out, okay, this is this formula, and you'll see why that's important here in a little bit. Okay, let's talk about and think about how we're going to use this information. We're asked to find the exact value for the cosine of pi over 12. We need to look at this list over here and come up with two angle measures that when we add or subtract them, so we're using our special angles from our unit circle, when we add or subtract them, they combine together to give us this 1 pi over 12 that we want. So if we look at this list, if you're looking at the actual angle measures, the ones that I have on the left in the blue, it's a little hard to figure out what would combine together to give us a 1 pi over 12. But if you are looking at these values with the common denominator, you see we have a whole bunch of options. We could subtract 3 pi over 12 minus 2 pi over 12. We could subtract 4 pi over 12 minus 3 pi over 12. We could do 9 pi over 12 minus 8, 10 pi over 9. Lots of options. We just need to decide which one we're going to do. So, Brendan, which one? Take your pick. Which two do we want to use to combine together to subtract to get us 1 pi over 12?
8 and 9.
Okay, so we're going to rewrite this cosine pi over 12 as 9 pi over 12 minus 8 pi over 12, right? Okay, we're going to have to go to our unit circle and find values. And so it's going to be easier if we are thinking about these numbers in terms of what they are with the reduced form also. So I'm going to do one other step, and I'm going to write this as this is equal to cosine 9 pi over 12 is equal to 3 pi over 4. Oops, I wanted to color code, sorry. 3 pi over 4. And then minus this 8 pi over 12 is what? 2 pi over 3. Okay, now we have to plug into this formula. And if you notice, we have cosine minus, so that means we are using this top form of the identity. So think about what that's saying we're gonna do. The formula says cosine of the first, so we're gonna have to figure out what the cosine of 3 pi over 4 is, times the cosine of the second, so cosine of 2 pi over 3. And then we're gonna do, oops, I said the first, nobody called me on that.
Wait, why are we multiplying?
This is the one with the minus. So we're looking at the second form of this, right? So we're multiplying, notice what the formula says, Cadell. It's saying cosine of u times the cosine of v. That's what those formulas are in the box.
Yeah,
So cosine of the first angle times cosine of the second angle. And then we're gonna do plus sine of the first angle times sine of the second angle. All right? Do you see how I just plugged into that formula? Yes, no, kind of, maybe. If the answer is no, you gotta tell me now. I will talk you through that again. We're doing cosine of two angles that are getting subtracted. So I'm plugging into this formula. And so we're doing this plus this. So that's what we wrote out here. Okay? All right, now we are going to unit circle. The cosine of 3 pi over 4. Guys, remember cosine? Now you understand why you did that delta math? The cosine of 3 pi over 4. Remember, for cosine, we're looking for x values. For the sine, we're looking for the y values. So that I don't get myself tripped up. I'm doing this off the top of my head. I better grab one. All right, cosine of 3 pi over 4. Marley, what is that equal to?
Negative square root of 2 over 2.
Yep, negative square root of 2 over 2. Good. And then we're going to multiply that times the cosine of 2 pi over 3. Ella, what is that equal to? So we're doing the cosine at 2 pi over 3. So find 2 pi over 3. And then we're looking at the cosine, which is the x value.
Negative 1/2.
There you go, negative 1/2. Good. Okay, and then we have plus, and now we're looking at the sine of 3 pi over 4, so the y. So Julian, what do we get for that? Root 2 over 2, good. Times, and then the sine of 2 pi over 3. Jonah, what does that give us?
Root 3 over 2.
Root 3 over 2. Beautiful. All right, we've got to clean this up, right? We have these fractions that are getting multiplied, so we need to clean this up. So this, when we clean that up, gives us a negative times a negative gives us a positive. And in the denominator, we're multiplying 2 times 2, so we get 4. And then over here, this, when we multiply that together, the square root of 2 times the square root of 3 gives us the square root of 6. And then in the denominator, we also get 4. So there's one other thing we can do, but there's only one other thing we can do, and that is we can put this over one common denominator. And that's typically what the format that you're gonna wanna see.
You can't do like root
And that you're
8.
gonna do that. Though they to add square roots, remember, I'm glad you asked that. To add square roots, remember, it has to be the exact same thing. So those are not like terms to be able to combine together, right? So it looks weird because it looks like you should be able to combine those, but you cannot. Marley?
I'm confused. How do you know it was the subtracting one and not the...
Because up here, to get to the pi over 12, we subtracted.
So do you get to choose which one you do?
Yeah, so like to get the 75 degrees, we might add 2 angle measures to get to 75, right? We could add 30 plus 45, or we could subtract some bigger numbers. I don't know, off the top of my head, I'm not coming up with anything off the top of my head, but we could subtract probably and get, yeah, if we did 135 minus 60, we would get 75 also. So in some instances, depending on what the values are, you might, like in this case, with the pi over 12, we had to subtract. In other examples, you might use the addition or the subtraction problem. Does that answer your question? Okay, good question though. All right, here's the deal, guys. I want to explain a little bit about this. You resist the urge to try to simplify that anymore because this is our final answer and that's what it's going to look like. Here's the thing. All of these problems, whether we're doing a cosine sum or difference formula or a sine sum or difference formula, the format of your final answer is always gonna look like this, okay? The difference, thank you, is gonna be whether this is a plus or a minus, whether the root 2 is positive or negative, whether the root 6 is positive or negative, that type of thing. So get used to this format of what the answer looks like, because if you solve a problem and you get something that doesn't look like this, then you know you've done something wrong. Okay? All right. Seems like there was something else I wanted to tell you about this, but I don't remember what it is, so we're gonna move on. What's your question, sweetie?
This takes a lot of work to do.
It's new and different, so it's gonna take a while to begin with, to get used to, but the more you practice, the easier it will get. I promise. Just as with the verifying identity stuff. When you first started that stuff, you were like, oh my gosh, this is impossible, this is really hard, it is gonna take forever. And now you're zipping through those problems like it's nothing, right? Okay. Other questions? Marley had a great question there. Other questions that you guys can think of before we look at another example? Okay. So because we used subtraction on the top one, I want to find two numbers on our unit circle that we can add so that we can practice with that formula. So I want to come up with two angle measures. You can use subtraction, but I want you to practice with both formulas. So what two angle measures can we use that if we add them together, we get 75 degrees. So the nice thing is this is in degrees, notice not in radians. So sometimes they'll be in degrees, sometimes they'll be in radians. So for cosine, there you go. Okay, so if we use cosine of 30 degrees plus 45 degrees, right? That gives us the cosine of 75. All right, so let's use our formula again. I want to use it from here rather than keep bouncing back and forth here. So cosine of 30 degrees plus 45 degrees. So that means using our formula that we're going to have the cosine of the first times the cosine of the second, and then minus the sine of the first times the sine of the second. Okay, take a look at that. Make sure you follow. Are we good with that, guys?
So you did the opposite there, is that what? You did the minusing instead of adding?
Well, if it's plus, look at your formulas. If it's plus here, then it's minus there. Okay? All right, I'm zoomed way in here. So, okay, so now we need to come up with what the values are for each of those things. So, the cosine of 30 degrees, David, what does that give us?
What's cosine again, X or Y?
X.
Cosine of 30 is root 3 over 2.
Root 3 over 2 times the cosine of 45 degrees, William?
Cosine of 45 radical 2.
Yep, root 2 over 2. Okay, and then minus the sine of 30, Raya? 1/2, sounds good. And then times the sine of 45, Elisa? Root 2 over 2, there you go, good. Okay, so now we have our values, so now we're multiplying this together. That gives us root 6 over, I'm gonna put this all over 4, I'm gonna skip that step because I know eventually I'm combining it together. So the numerator here we multiply and we get the root 6, right? The numerator here, when we multiply that, we're gonna get root 2. So we get the square root of 6 minus the square root of 2 all over 4. Now, guys, the way we solved it, that's what we get. If you had used other numbers, like maybe if you had used the 135 minus 60, the order would have maybe been switched and you'd have like negative root 2 plus root 6 all over 4. But that means the same thing, right? The signs in front of each of those individual terms is the same. I hope that makes sense, right? But are you seeing a pattern with what the format's gonna look like in terms of what your final answer will look like?
Do we have to memorize the formula?
No, I will give you those formulas. I will give you those formulas. Okay, yeah, no, okay, let's look at,
You don't even have to. Like,
you're not memorizing, Cadell, you are not memorizing that. If
stop being an idiot, dude.
Wait, we use
Stop
the
being
unit
an
you're gonna
circle on the
memorize
test.
it, okay, you look at your unit circle and you see that the first, in quadrant 1, these are your
Yeah, but we get unit circle
special
on the test.
angles, right? And so then you can come up with, you know how to figure out, you did this back in 3rd grade or whenever. You
Oh,
can
it's
come
just
up
the
with
first-
common
it's
denominators.
not hard.
Oh,
That's
it's just
first
like the
quadrant.
first- no, it's like the first 3.5
Yeah,
quadrants.
okay.
Oh.
Hey, stop being dumb, dude.
You got this. Be nice. Okay,
No, I just didn't realize it. Like,
sine formulas, please notice they are a little bit different here. If we're doing sine of, and we are subtracting, then in this, on the other side, it's still also subtraction. So if it's plus here, it's plus here. But notice in the sine formula, the sines and cosines are mixed together, right? With the cosines, remember the cosines were together and then the sines. This formula, it's a little bit different. So you'll see why that's important. I'm kind of stressing that now and you're kind of like, yeah, whatever, lady. You'll see why, I promise. Okay? All right. Prove this identity. So if you notice, we definitely want to work on the left-hand side. It's more complicated, so we're not going to do anything on the right-hand
Are all the
side.
side ones proving the identity?
No. Though they might also be like
I need that guy.
these top ones also. Okay. And good, I do have an example of that type. Okay. So this is saying sine, and we have subtraction, so we want to make sure we are using the right form of the formula that we're going to use, the identity. So we're going to use that identity, the top one, right? So we want to write this as the sine of the first, which in this case is pi, times the cosine of the second, which is x, and then minus the cosine of the first times the sine of the second. If you notice, this one has x's in it, right? There's only a few things we're gonna be able to simplify here. Okay, we need to figure out what the sine of pi is equal to. And if we go to where pi radians is, Cadell, what is the sine?
0.
0. So we get 0 times the cosine of x, which, guys, that just gives us 0. And then we have minus, Hillary, what's
How do
the,
you know what the cosine of x is?
doesn't matter. If we're multiplying by 0, it's just gone,
Oh, yeah, okay.
right?
I thought you meant like, oh, I wasn't looking. Yeah, you're right.
Do you see what I mean?
Yeah.
If we're multiplying by 0, it doesn't matter what the cosine of x is. I mean, it's still just the cosine of x, but if we multiply by 0, then that becomes 0.
Yeah.
Okay, what about the cosine of pi, Hillary? Okay, good. So we get minus -1 times the sine of x. And if we have minus a -1, that becomes a +1. Guys, you just verified that identity. Oh yeah, left-hand side equals right-hand side, right?
Let's go.
Nice. Excelente. One other example we're gonna look at And this always blows everybody's mind, and I'm not sure why.
Without using a calculator?
We haven't been using
What do you need a calculator?
We haven't been using a calculator at all. Just seeing that though, it gives you the shakes or something.
I'm shaking over here.
If, would it help if it said with using unit circle? So should I change this to say with unit circle?
I just don't get how a calculator would do that.
Okay. Because if you're not thinking unit circle when you see that, you're thinking you're just gonna plug those values in and figure out what it is. But that's not what we're doing.
Do you need a calculator on this test?
Not for this stuff. For the next stuff we're doing after this, you will want calculator. No, I take that back. You're not getting calculator for that
another
either,
unit
so
after
you're
this
not gonna
test?
have one other lesson
We
That
get
was
a
the last
calculator.
unit.
after this one. This is our last unit.
Is there a calculator exam?
When is your exam? Your exam is on May 20th.
Wait, what week are we
Do
on
we
right
have any more
now?
tests?
April 22nd.
Yes, one more quiz, one more test.
Shoot.
Okay,
We only got a little bit.
yeah.
So
It's a
exam
part
review.
of quiz though.
Are we gonna have a bunch of those like exam review packets?
Yeah, I have sent off for copying your study guide already.
If the seniors are already done, do they have to do that exam review, or what's the class gonna be like for them?
You're not gonna have that much, there's like a day or two maybe at the end where you're,
Just sit
might be
there.
in class when we're doing review, but
You can help me,
we're
sorry.
working on up
You
until
still
then,
with me?
so. Yeah,
We just sit around
it
and-
won't hurt you to
Yeah.
do a little bit of
Maybe
review
college
of
off
pre-calculus to get you ready for whatever math class you're going into.
You have to take that.
All right, hold on just a second, let's finish this. We are almost done, we got sidetracked here. Guys, take a look at what this says.
I just gotta do well on these next quizzes.
What are you doing if you get below?
He's got to lock in.
Yeah, I have to watch it.
Could you graduate?
Okay,
You
guys,
have to take the exam.
take a look at this formula, take a look at what is written here, okay? This is, what we've seen so far with our problems is that we were given something that looked like the left-hand side of our identity, and so we wrote what it was equal to on the right-hand side. Now, however, if you notice, this looks like the right-hand side of one of your identities on page 13. So you have to kind of flip back and forth between page 13 and page 14 here. If you notice, I'm seeing sines and cosines mixed together, and I'm seeing a plus sign. So we have to figure out which of those four forms of the identities, those formulas that we saw on page 13, is this asking us to use? Sines and cosines are mixed together. Look on the right-hand side of each of those equal signs. Sines and cosines are mixed together, and I'm seeing a plus. So what should we say that this is going to be equal to? What's the left-hand side going to be? Is it cosine or sine? Sine, good. And is it
Wait, how did you
x
know?
plus y or is it x minus y?
Plus.
It's plus because this is plus. Okay, so do you see why?
Yeah.
Okay, sines and cosines are mixed, so we know we're dealing with a sine formula because for the cosine
Yeah.
they're together, cosines and sines. So they're mixed, and then this sign tells us if it's plus here, that's gotta be plus here. So think about what this is saying. This is saying we have the sine of 63 degrees plus 27 degrees. And we can add that together without a calculator, right? 7 plus 3 gives us 10, carry the 1, so we get 6 plus 1 is 7 plus 2 is 90. So we get sine of 90 degrees. Guys, that's on our unit circle. What's the sine of 90 degrees? 1. Booyah. How pretty is that?
It's a game.
It is kind of like a game or a puzzle with this as well. You're right. I'm sorry?
I like the.
Good, I do too. So if you notice what your classwork / homework is, it's in the notes packet, it's the next couple of pages. There are, if you look though, there are some that are tangent and then there are some that are sine and cosine. So you are only gonna do the ones that we've talked about. You're not gonna do tangent ones because we haven't talked about those yet. So on those next few pages, you are looking for the sine and cosine
So
problems.
don't do tangent?
Those are the ones you're doing. So you're doing that. So 1, 2, 4, and 5,
Oh, we knocked this out in like 10 minutes.
and 7, 8, 10, 11.
Oh, no, 6.
Does that make sense, guys?
Wait, I feel like we should write these down.